Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. For this video, I'm going to deliver about numerical solution of partial differential equation, or in other words, we want to know the numerical methods to solve for partial differential equations, where after this I will call partial differential equation as PDE. Okay, so if you still remember what we have done during our EQT 102 Engineering Mathematics 2, we actually have learned about on how to find the actual solution or analytical solution for partial differential equation, especially in heat and wave equation, by using separation of variables method. I call it as SVM. Okay, so if you still remember separation of variables method, it involves the partial derivative. You need to differentiate partially your uxt from the solution, from the product solution, and then it requires separable equation where you need to separate the variables, and then using back the product solution uxt. Okay, uxt equals to x as a function of x dot with your t as a function of t. So this is how you get the solution of PDE, the heat and wave equation, by using separation of variables method. But for this semester, in this topic, we're going to discuss the alternative method to find the solution of PDE, to find the solution of partial differential equation by using numerical methods. Okay, we want to solve for PDE numerically. Alright, so in this topic, we are just concentrating on only one method. Okay, we call it as finite difference method. Okay, so before we proceed to the finite difference method, I would like to start the lecture, okay, with the classification of PDE here. Classification of PDE, partial differential equation. Alright, so for example, we have heat, wave, Laplace, Poisson equation, and then how you can determine whether it is a heat equation, wave equation, Laplace equation, and Poisson equation. Okay, so we must begin with the general form or general equation of PDE in two independent variables x and y, for example. Alright, okay, let's say we have this equation. Okay, this equation is a general form of second order linear differential equation for partial differential equation, where you have A here, B, C, D, E, F, and G. These all we call it as a coefficient. Okay, and then you have this A as a function of x and y. Okay, this is not really coefficient, we call it as a function. Okay, and then for A, okay, as a function in front of del square u del x square, only involve partial derivative. Okay, second derivative of x, okay, variable x. This one second derivative of x and y, mixed partial derivative, and then this is the second derivative of y. Okay, since we want to know what is A, B, and C here for the conditions, so that we can simplify the general equation into most simplified equation, where we have only A, B, and C. Okay, so now we want to know whether we have heat, wave, Laplace, or Poisson, or it can be mixed type function, it can be parabolic, hyperbolic, elliptic function. Okay, by looking at the b square minus 4ac. Is it equals to 0? Okay, is it less than 0, or is it greater than 0? If you have b square minus 4ac equals to 0, you have a heat equation, or in PDE we can classify it as a parabolic equation. So I can ask you, heat equation is a type of parabolic equation. Is it true or false? So the answer is true. Okay, or I can give you a function like this, and then you must check for b square minus 4ac. If you get b square minus 4ac equals to 0, I can ask you determine the type, the classification of the PDE. So dia bagilah, okay, option 1 is parabolic, option 2 is hyperbolic, option 3 is elliptic. Okay, so you must choose which one is the most suitable classification given the specific equation, and then you can check the condition. Okay, so I also give you example here. Okay, so we hold tightly our simplified equation of PDE here. Okay, this one, and then we have, let's say, classify each of the following constant coefficient equation as hyperbolic, parabolic, or elliptic. Okay, so now we check. So this is the standard equation. Sorry, this is the simplified from the standard equation, and then we just try to map. Okay, so we have uxx. So this one is del square u del x squared. This is actually uxx. Okay, auxx. Okay, where a is a function of x and y, plus b u, this one is x and y. Okay, plus c, this one, so you have u y y. Okay, so that you have here, you can check your coefficient of a is 1, your b here is, you just have the coefficient of 2, and then your c is 3. Okay, and then when you check b square minus 4ac, so that you have 2 square minus 4 times a, which is 1, times your c, which is 3, so that you have negative 8. Negative 8 is less than 0. Then go back to our definition and classification here. When b square minus 4ac less than 0, so that we have the elliptic equation. Okay, so elliptic classification, where elliptic is a type of apa? It can be Laplace of Poisson equation. Right, so that we have elliptic. And then the same thing to this one, you can check for a, b, and c, so that you have hyperbolic, which is greater than 0. Okay, greater than 0, so that you have this one. Okay, hyperbolic function. Okay, alright, so hyperbolic is a type of wave equation. Right, and then you can proceed to this one, which is parabolic, equals to 0. And then look here. Okay, for this example, okay, I put the simplified equation here. Then you check b square minus 4ac, so that you have negative 4y square. You're not getting the specific number, because you have a variable of y square here. Okay, so that let us check. Okay, so we need to check whether we have y, this y, the condition of y greater than 0. What happen if you have y equals to 0, and what will happen to your equation if your y is less than 0. Okay, let's say if y greater than 0, so let us choose y equals to 1 lah, because 1 is greater than 0, right? So by substituting y equals to 1 into our solution here, so we have 4. Okay, y equals to 1 square, so that we have negative 4. Negative 4 is less than 0. So when you have b square minus 4ac less than 0 here, so you have the solution of elliptic. Okay, so what will happen to your equation, okay, when you have y equals to 0? So when y equals to 0, we will get equals to 0 lah. Equals to 0. It goes 0. So b square, okay, minus 4ac goes 0, so that we have a parabolic, type of parabolic. Okay, and then when y is less than 0, let's say what, just pick a number which is less than 0. Let's say we have negative 1, so that we have negative 4, okay, times y square, which is -1 square, then we will have less than 0. Still we have b square minus 4 is c less than 0. We will have elliptic. Okay, so that what we can conclude that here, if y equals to 0, we have a parabolic. If y is not equals to 0, then we have elliptic. Okay, alright. So probably I can ask you, alright, okay, I can ask you the type of equation like this. I give you this function and then I can give you the statement. Okay, for example, okay, this is the question. I give you one equation here. Okay, you can paste it here, and then my question is, choose the true statements. Okay, so probably checkbox. You have checkbox. Okay, so when you have checkbox means that it might be more than one correct solution. Okay, so my statements here probably I can put if y greater than 0, it is elliptic. So it is true, right? So you need to choose this one. Okay, the second statement is if y equals to 0, okay, the equation, the classification is hyperbolic. Okay, the second statement. So this is wrong. So I'm not choose this one. Okay, the statement 3 is if y not equals to 0, the equation or the classification of this function could be elliptic. True or false? So true. So I have 2 correct statements. So this is the way I can ask or test your understanding regarding to the classification of partial differential equations. So probably after this you can proceed with example 5. Okay, so the same thing here. You can look at the on how we can justify the type of classification that you have from the given function. Okay, so for the next video, I would like to discuss the method, the numerical method to solve for partial differential equation. Stay tuned.
I'll be there whenever you want me. I need somebody who can love me at my worst.